Last lesson we saw some techniques to solve exponential equations and inequations. Today we're going to harness the power of logarithms to give exact solutions. So just say we were solving 2 to the x equals 11. Now what you might think is, well, 2 to what power gives me 11? Or I might try equate the bases, but we'll find that these two numbers just don't work. Let's have a look on our calculator what the answer is. So I'm going to go and run a solve 2 to the x equals 11 for x. Now I know that the answer is going to be somewhere between 2 and 3, okay, because 2 to the power of, no, 3 and 4, so 2 to the 3 is 8, 2 to the 4 is 16, so it's somewhere between 3 and 4, but I don't exactly know what it is. Well, this says it's x equals 3.459 dot 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 dot, okay, and that continues indefinitely. I wonder what the exact answer is. Log E11 over log E2. Interesting. All right, so how are we going to solve these and give an exact answer? Well, here goes a method. What we can do is, this is an equation, so I can add 3 to both sides, I can take away 3 to both sides, I can multiply both sides by 10, or I can log both sides. So what I'm going to do is I'm going to take the log 10 of both sides. So I'm going to do log 10 2x equals log 10 11. So I'm just essentially log 10ing both sides. All right, now why log 10? Why that particular base? Well, you can choose any base you want, but my strong suggestion is you choose one of two bases, log 10 or log e, all right? Now, I'm going to show you why it doesn't matter which one you choose as well. So what I'm going to do is use that rule that allows me to bring that x over to the front there, okay? So I'm going to write this as x log 10 2 equals log 10 11. Now I'm going to divide both sides by log 10 2. So that leaves me with x equals log 10 11 over log 10 2. All right, now I know that the calculator said it's log E11 over log E2, but again, it doesn't matter what base you choose, and I'm going to just prove it to you by getting the approximation and then approximating log 10 11 over log 10 2. And we note that we get exactly the same approximation. So you can choose whatever base you want, but when choosing a base, my recommendation is you choose either 10 or E. But if you want to do what you're most frequently going to do next year, which will be the base E, start that up now. That's a good thing to start up now. Okay. All right, this one here, let's go for it on this one. I'm going to show you two ways of doing this problem. Okay. All right, so the first method will be to log both sides. Now this time I'm going to go log E. 3 to the 2x take 1 equals 28. Oh no, equals log E 28. Now that equals 2x take 1, so we're going to grab that and stick that to the front. Log E 3 equals log E 28. All right, now what I can do is divide by log E3. So I've got 2x take 1 equals log E28 over log E3. All right, now let's solve that. So I'm going to go 2x equals log E28 over log E3 plus 1. And finally, I'm going to multiply this by a half and multiply this by a half as well. So that's going to be x equals log E28 over, fast running out of space here, log E3. Now I'm multiplying this by a half, so that's going to be 2 log E3. And I've got to multiply this by a half as well, so it's going to be plus a half. All right, so there's one answer. All right, is there an easier way to do this problem? Yeah. All right, so what we're going to do is say, I'm going to convert this straight into log form. So I'm going to say that this is log 3 28 equals 2x take 1. So I've just changed the form of that. 3 to that equals that. Now I'm going to go and transpose it. So I've got 2x equals log 3 28 plus 1. And now I'm going to go x equals a half log 3 28 plus a half. Now notice the difference between these two. Right, so by appearances they do look significantly different, but I assure you these things are exactly the same as each other. Okay, again, here is my proof. I've got ln natural log 28 over 2 lots of the natural log of 3 plus a half, and that approximates to 2.33 dot dot dot. Now I'm going to go a half multiplied by log 328 plus a half, so there's my other answer, and that's not a good sign at all, is it? All right, what has happened? All right, just unpausing this video now. I had to stop and think about that. Now notice the change in the calculator from when I paused it. What I did was shoved some brackets around there. Now what this did was did ln, or the natural log of 28, and then it divided it by 2, and then multiplied it by the natural log of 3. Sticking that all in brackets will mean that it does this multiplication and then divides ln 28 by the result of this. So I forgot to put some brackets in here. Now the best thing you can do to overcome that issue is shift and divide, use the fractions template, and it will sort all of that stuff out for you. Okay, notice that with that correction we got exactly the same answer. So that is exactly the same as that. And again, what you need to do is just be really careful checking your answers in the back of the book and places like that, because some log answers can look vastly different yet be exactly the same as each other. So very important that you do check your work. All right, let's do this one here. Now, the technique I'm going to use for this one here is to log both sides. So I'm going to choose a base. Now, just to sort of vary it up, I'm going to go back to log 10, 0.2 to the x, less than and equal to log 10, 12. Okay, I'm going to grab that x and throw it over there. X log 10, 0.2, less than or equal to log 10, 12. All right, now here is an interesting problem. Okay, this is an interesting problem. Now the rule will be that this, so generally speaking, a negative number, if you look for a negative number, you'll look for a negative sign out the front of the number, and that there would be negative. Now the thing to note about log 10, 0.2 is that that is actually a negative number. Now I know that there's no negative sign there, but it's actually a negative number. Now, if you note that the number being logged is between 0 and 1, not inclusive of 0 and 1 themselves, then this overall result will be negative. Now, why? How? What's happening? All right, let's explore a case here. So I'm going to go log 2 half. All right, so that's in fact a negative number. All right, log 2 a half is a negative number. Now, why is that the case? Well, this can be written as log 2, 2 to the negative 1. And that negative 1 can come to the front here and go negative 1 log 2, 2. Log 2, 2 is just 1, so the answer is actually negative 1. So log 2 a half is in fact negative 1. Okay, now all of these fractions here, so this would be like, so when I'm doing this, I could rewrite this as log 10 and 2, that's 2/10 or 1/5. Okay, now how can I rewrite 1/5? That's the same as log 10, 5 to the negative 1, using the negative index rule, which is the same as negative 1 multiplied by log 10, 5, or negative log 10, 5. And now it looks more like what we're typically used to seeing as a negative number. Now, why is this an important discussion? Well, to solve for x, what I'm about to do is divide both sides by log 10, 0.2. Now, I know that this is a negative number, so I'm going to go x greater than, I'm going to flip the inequality, log 10, 12 over log 10, 0.2. Okay, you don't need to make these moves here, but you just need to be aware of why the sign flips when I log a number between 0 and 1. All right, I'm just going to clear out some of the stuff that's going on here. So edit and remove. Okay, let's hit this problem now. So we've got 0.4 to the x greater than 0.63. All right, so let's choose log e, 0.4 to the x greater than 0.63. I keep forgetting to log both sides. Log e, 0.63. All right, now I'm going to grab that x, log e 0.4, greater than log e 0.63. All right, now I'm going to solve for x. So x, now I'm going to divide by log e 0.4. Now again, why am I doing that? Quick explanation one more time. 0.4 is 4/10, which is 2 on 5. Okay, now what I'm going to do is rewrite that as log e, and I'm going to write it as 5 to the negative 1, 2 to the negative 1, which is the same as log e, 5 on 2 to the negative 1. Now I'm going to grab that negative 1 and throw it at the front, negative 1, log e, 5 on 2. So it's actually a negative number. Okay, so this here is a negative number, so when I divide by a negative, I have to flip the inequality. Log e 0.63 over log e 0.4. All right, one final one here, so hopefully you get the drift on this. So log, I don't know, 15 if you want, 0.7 to the x greater than or equal to log 15, 0.3. Okay, let's all do this in one move. Not log e. Log 15. What is it? 0.7. Okay, this one here. Okay, so what we're going to do with this one here, I'm going to write this as 2 to the x, take 3 plus 2 over 2 to the x equals 0. All right, now, why have I done that? I'm going to go let a equal 2 to the x. So that's 2 to the x there. A take 3 plus 2 over a equals 0. Now I'm going to multiply all of these terms by a, and I'm left with a squared take 3a plus 2 equals 0. Alrighty, now I note that I've got a quadratic. In fact, this is a classic hidden quadratic. So hidden quad. All right, so here let's cross that. So we got 1, 2, a, and both of them are negative. A take 1, a take 2 equals 0, a equals 1, a equals 2. All right, let's go ahead and sub back in. So I've got 2 to the x equals 1. Now, that means, therefore, x could be 0. I've got 2 to the x equals 2. That means x is equal to 1. All right, so both of those solutions are true for this. Both of them could be feasibly subbed in to get those. So, no worries. Okay, so the exercises for this will be 13F. Okay, good luck with it.